Hello, I'm Professor Von Schmohawk, and welcome to YU. In our last lecture, we saw how the people on my primitive island of Coco Loco discovered addition and subtraction. Once we had invented addition and subtraction, the Coco-Loconians could calculate very complicated coconut transactions with great precision. But we soon found out that with only addition and subtraction, some calculations could take a very long time. For instance, once a year, everyone on Coco Loco must donate 3 coconuts for the annual feast of Mombozo. So, if all 87 inhabitants of Coco Loco each donate 3 coconuts, then how many coconuts will we have for the feast? Before we discovered multiplication, we had to add 3 87 times to answer that question. However, with multiplication, the answer can be found with a single calculation. Multiplication is just a tricky way to do repeated addition. For instance, when the king of Coco Loco wanted to tile the floor of his rectangular hut with very expensive imported Bongo-Ponganian tiles, we needed to know exactly how many square tiles to buy from the Bongo-Ponganians. We knew how big each tile was, so we could have marked the floor into little squares and counted all the squares. But with multiplication, it was much easier. All we had to do was to figure out how many rows of tiles we would need and how many tiles were in each row, and then multiply the two numbers. Since we figured it would take 6 rows of 10 tiles, we knew that we would need 6 times 10, or 60 tiles. But then someone suggested that it would be better to lay the tiles down in vertical rows instead of horizontal rows. We would then need 10 rows of 6 tiles. At first we thought that this might require a different number of tiles. Then we realized that 10 times 6 is also 60, so you will still have to buy 60 very expensive imported Bongo-Ponganian tiles. It doesn't make any difference if you multiply 6 times 10 or 10 times 6. You get the same number. We originally called this the commutative property of multiplication of very expensive imported Bongo-Ponganian tiles. After a while, we decided to shorten the name to the commutative property of multiplication. We can write this property as A times B equals B times A. In algebra, a dot is often used as a multiplication symbol to avoid confusion with the letter X. Just like addition, multiplication is a binary operation which, as you may recall from our previous lecture, is a mathematical calculation involving 2 numbers. These numbers are called operands, and in the case of multiplication, these operands are multiplied together to produce a result called the product. In multiplication operations, the operands are sometimes referred to as factors. Even though multiplication is defined as a binary operation, you may often see multiplications involving more than 2 operands. Just as in addition, this is possible because pairs of operands can be multiplied one at a time, with each product replacing the pair. In this way, an unlimited number of operands can be multiplied sequentially. On Coco Loco, we soon discovered that the commutative property also applied to situations where more than 2 numbers were multiplied together. For example, let's say that you had 24 boxes. You can stack these boxes in several different ways. For instance, you could arrange them in 3 rows of 4 boxes and stack them 2 levels high. Or you could arrange them in 4 rows of 2 boxes and stack them 3 levels high. Or you could arrange them in 2 rows of 3 boxes. and stack them 4 levels high. It doesn't matter in which order you multiply the dimensions of the stack, it will always add up to the same number of boxes. We can apply the commutative property to multiplication operations involving any number of operands. By swapping adjacent pairs of numbers, the operands can be reordered in any way that we please. For instance, in this multiplication involving 4 operands, the 2 at the end could be moved up to the front, or the 5 could be moved to the back. So 2 or more numbers which are multiplied can be reordered in any way without affecting the result. As we saw in the previous lecture, the same holds true for numbers which are added. Addition and multiplication are both commutative. Commutative properties are important algebraic tools that allow us to rearrange groups of numbers which are added or multiplied. In the next chapter, we will discover several more properties which we will add to our tool chest of mathematical tricks.